So the whole point of this unit circle business was to, well, one, see where the special angles are on the unit circle and then also figure out what their exact values are. We've done this in the first quadrant. We've seen videos of this, or I showed you videos of this earlier in the playlist here, so I'm not going to go over where these come from. But remember that the coordinates of all these points are simply the x-coordinate is r times the cosine of theta, and y is r times sine of theta, whatever the angle just happens to be. Also remember that because we're working on a unit circle, that just means that the radius is 1, and so we can just essentially erase them because they're just times 1. Now, in this video, we want to talk about how we can use this first quadrant here to evaluate the trig functions for their multiples. So for example, 120 degrees, 135, 150, and so on. The reason that we can't just do it normally is because I can't make a triangle with 120 degrees. So we'll use 120 as an example. Okay, well, how do I use this? Here's a 120 degree angle. What I'm going to do, well, first off, let's just see. I can't draw a right triangle, and a right triangle is really what we need, at least as far as we know in terms of using right triangle trig. It's dependent on having a right triangle. So I can't actually do this kind of as we have learned it. What I can do is I can make a right triangle. So what we're going to do is we're going to take the ray or some point on the ray, and we're just going to drop it straight down. And the reason I'm using this length out up to 1 is because, again, 1 is the radius of our unit circle. And I'm just going to drop it straight down. Sorry about that. So it's perpendicular. If that's the case, well, remember that this all the way right here, that would be 180 degrees. That would mean that the leftover angle here, I'm going to call this theta sub r, that's going to be 60 degrees. Theta r equals 60 degrees. Okay, this right here, theta sub r, that is what we call the reference angle. Reference angle. And the way you form that is, as we have done, you just drop from the ray straight down to the x-axis, wherever that happens to be. If your angle ended up maybe down here, say, then your reference angle you would draw going upward, like so. And then this would be your reference angle, theta sub r, I call it. Okay? If your angle is down here, then the reference angle you would use would be this one right here, and it would be right there. That's your reference angle. Now that I've cleaned it up, and notice the reference angle is always an acute angle. This is because, and I should maybe write that down, always acute. Because, again, I can't have a right triangle if it's not an acute angle. If it's an obtuse angle, you don't have a right triangle. And if it's a right angle, well, you can't have two right angles in a triangle. It wouldn't work out. As far as we know, anyway. So this is your reference angle. The reason this is nice is because you know all about this triangle right here that I'm going to highlight. You know all about this triangle because this is a 30, 60, 90 triangle. We've seen that, well, actually twice already. We've seen it here in red, and we've also seen it in green. Oh my God, sorry about that. You've seen it. And so we know all about it. If the hypotenuse is length 1, then we already know that the opposite side, the long side in a 30, 60, 90 is root 3 over 2, and the short side is 1/2. There you go. Now you just have to be careful here because what did we just say? Well, to get from the origin, because remember, we're trying to find cosine of 120 and sine of 120, which would be the x and y coordinate, right? The x coordinate equals cosine of 120 degrees. That was the whole point of this unit circle business. And y equals sine of 120 degrees on this red point right there. So what we're saying is to get the coordinates you went 1/2 in the x direction which is to the left. And then you went root 3 over 2 in the vertical direction straight up. So since this is 1/2 and you're going to the left, this should actually be negative 1/2. This is really, really important there. And I'm positive root 3 over 2 right there. And so the x and y coordinate of this point right here should be negative 1/2 comma root 3 over 2. Again, that tells us that cosine of 120 degrees is equal to negative 1/2, and also sine 120 degrees is equal to root 3 over 2. What's nice about the unit circle is that you can also see this geometrically with the symmetry that is built into the circle. So let's take a look here. Notice we're going to focus on these yellow rays that I'm going to highlight here. So that's the 120 degree angle, and this is a 60 degree angle. Again, remember these are the angles from 0 out to there and then 0 out to here. If you fold the paper over, and if you have this on your paper and you fold it in half along the y-axis, then this point gets kind of mirrored over here. From the 60 degree angle, it gets mirrored to the 120 degree angle. And so what I'm getting at is that wherever it is, this triangle right here, this giant red triangle, and this giant red triangle would essentially be mirrored and thus symmetric. They'd be the same size, have the same dimensions. Thus we can see, if we look at their y-coordinates, hey, wait a minute. They intersect the circle, they're on the circle at the exact same y-coordinate. And so it makes sense that they're both root 3. If the 60 degree angle has a y value of root 3 over 2, then so should the 120. And likewise, this horizontal distance here should be the exact same as this horizontal distance there. So if it's 1/2 to the right on the 60 degree, it should be 1/2 just to the left now for the 120 degrees. And so this is the whole point of the unit circle, is that we can use just what we know about these 5 angles here to evaluate the trig function for any multiple of them, whether it's 120, 135, 150. Heck, it could be like 600 degrees, and it would just end up 600 degrees would just be, let's see, that's 360 plus, let's see, plus 180 would be 540, and then plus, let's see, plus 30, plus 45, plus 60. So this angle that I just drew would be theta equals 600 degrees. And the reference angle you would use, you'd really just end up using this angle right here in green. And your reference angle there would be just 60 degrees. So that's the whole point of this unit circle. It's really not that bad, at least, well, I mean, I'm the teacher, so maybe my opinion doesn't really mean much to you, but it really, really just takes practice. And once you kind of get the hang of it, it really isn't that bad.